We began by restructuring our physical environment. The agricultural epoch marked the extension of human agency into the soil, altering biological rhythms for civilization. We then mastered physics to mechanize our labor. Steam and steel replaced human muscle, accelerating production and reorganizing society around factory floor efficiency. By the late 20th century, we translated human knowledge into binary codes. We built machines performing millions of operations per second, following our explicit commands. Today, we have moved beyond manipulating data and into building autonomous algorithmic infrastructure. Digital tools passively wait for a human command. Algorithms operate autonomously, learning and making decisions independent of direct supervision. Artificial intelligence actively governs and co-constructs our physical, social, and political reality. This side-by-side comparison shows the structural change in how we process information. On the left, traditional software uses a rigid decision tree with human-written deterministic rules. On the right is a multi-layered artificial neural network. Deep learning systems receive unstructured data. As information passes layers, nodes sequentially activate, extracting hierarchical features without explicit human instruction. When the network makes a mistake, it learns from the error through a mechanism called backpropagation. An error is calculated, and a signal flows in reverse. As it moves right to left, it dynamically adjusts the mathematical weights of the connections, refining the system's accuracy. Because these weights adjust based on vast amounts of data, the machine provides an output based on probabilistic inference rather than deterministic calculation. We have surrendered the practice of writing explicit instructions for systems that navigate statistical uncertainty to find patterns beyond human perception. Deep learning networks analyze existing data to find patterns and extrapolate them to generate new realities. This loop is a generative adversarial network, or GAN. A generator produces an abstract output. A discriminator critiques it. It iterates until resolving into a synthetic artifact. Meanwhile, a transformer architecture maps and weighs the probabilistic relationships between words across a sequence of text. By training on massive corpora of human knowledge, the transformer synthesizes information and context without possessing subjective experience or consciousness. In practice, these models automate academic research and provide personalized, scalable educational tutoring. The machine acts as a probabilistic co-creator, shifting the human role away from information retrieval and toward the strategic orchestration of synthetic knowledge. The data required to train these models is extracted directly from human behavior. Every click and location ping feeds a massive data reservoir. This extraction powers data capitalism, an economic regime where human experience is quantified and commodified. These algorithms act as architects of choice. The system dynamically closes off certain routes and highlights others based on the continuous behavioral feed from the data reservoir. Recommendation systems utilize a feedback loop designed to maximize engagement, prioritizing platform stickiness. Initial choices feed data back into the system, refining its next suggestions. The available space tightens, restricting the user into an echoing loop circling back on their existing preferences. This narrowing process curates social connections, limits our informational universe, and engineers new behavioral norms. Data capitalism utilizes these recommendation systems to replace overt coercion with invisible algorithmic nudging, commodifying human attention and eroding autonomous decision-making. This nudging is moving from digital screens into the physical reality of urban infrastructure. To function, the smart city relies on a pervasive surveillance infrastructure that monitors the physical environment in real time. This infrastructure enables algorithmic governance, where we delegate public administration and resource allocation to opaque computational codes. Urban data flows into deep learning networks. The system processes this activity and shoots predictive action vectors back down to direct patrols and adjust traffic flows. Citizens exchange their privacy and submit to ambient behavioral monitoring in return for promised efficiency. Because these decisions are hidden behind layers of code, the outputs present themselves as objective mathematics, masking the historical biases encoded in their training data. When we allow these inscrutable models to decide the allocation of resources and policing in real time, we remove these choices from public debate. This mechanization of control bypasses democratic deliberation, replacing the legislative process with statistical proxies. In this architecture, the citizen is layered beneath smart city infrastructure, data markets, and neural networks at the top. The defining feature is opacity. The neural network acts as an impenetrable black box, casting a shadow over the layers it controls. This exposes a core paradox. The technology possesses the capacity to democratize individual knowledge, yet it centralizes the power to influence populations into the hands of a few monopolies. Algorithmic control does not threaten autonomy through explicit force. It controls by invisibly curating our options and desires, bypassing the need for informed consent. Treating AI as a passive technical tool ignores its role as an infrastructural architect. If we are to maintain our agency, we must demand aggressive democratic oversight and a renegotiation of power in the 21st century.